Hi, so this is the lecture on 5.5, which is irrigation. It goes very nicely with the agricultural practices that we just had, so watching these together is good, and it's going to get you ready for the salinization lab. So we use water to grow food. In fact, most of what we use fresh water for in the world is to grow food. So 70% of all freshwater use um, is for agriculture. Okay, so when you water, oh, and I should say that this is on page 15 in your notes. So the largest use of fresh water, 70%. So it increases productivity. 16% of agricultural land is irrigated and it produces, oh, I'm sorry, I'm on top of this. Let's see if I can move it over. Oh, sorry. Okay, so if we just go back. All right, it produces 40% of the world's food supply. So 16% of agricultural land is irrigated and it produces 40% of the world's food supply. Okay, so let's see, not on top of the words here. Okay, so waterlogging is when roots can't get enough oxygen. So when you water with irrigation, you often overwater and it can pool up. So that's what waterlogging is. It like drowns the roots of the plants. And good old salinization. All right, so too much salt is left behind through evaporation or saltwater intrusion. So if water from the ocean comes in and gets too salty, that can lead to salinization. And then also in places where it gets where it snows a lot, they use rock salt to melt the snow, and then that can make the runoff can get into crops and get things saltier. But the biggest reason for this is that we water with fresh water from the hose, which contains a teeny tiny little bit of salt, like I said in the last lecture, about 0.005% salt. So when the water evaporates, the salts are left behind. And when too much salt is left behind through evaporation, then the plants cannot grow. They cannot germinate and they cannot grow. And so the amount of salt that you have to get to, when you think about that, it is really expensive to get that salt back out. So we'll be talking about why that is. So the efficiency, the percentage of water that reaches the plant roots is not lost to evaporation or runoff, is wasted. So there's a lot of waste in this, but there's ways to make it better. So furrow irrigation is when you have these long furrows in between, so you can flood the crops with water, and the plants will be fine. They won't get waterlogged, and they won't get too dry. They won't get too wet. But then all this extra water runs off. So this is furrow irrigation. And so you're writing this in on your notes right here. So the trenches fill up. It's 65% efficiency. The benefits are low effort and cheap, but you can still have waterlogging and salinization. So you'll write that into that little chart there. So flood irrigation, I guess I'm just going to have to keep, sorry, let me exit. Okay, cool. So flood irrigation, you flood the field and let the water soak in. It's 70 to 80% efficient. It's cheap and easy, but you still get waterlogging and irrigation. Spray irrigation is pumped through nozzles and sprinklers. That's 75 to 95% efficient. It's more efficient, but it costs a lot more and it uses more energy. So you're wasting water when you're doing this. And you might see a lot of times they do it when it's really hot outside. So you can be judicious when you're doing this and be better about it. But sometimes it's only done on like just a calendar schedule instead of when it makes the most sense to from the standpoint of what the weather's like that day. Then drip irrigation, slow dripped hose are buried on top. So you can see here that there's like a little tiny little drip coming out of the water. So this is 95% efficient. It is the most efficient way to water plants. It reduces weed growth, keeps the surface soil dry, and is especially useful with perennials. It's the most expensive though, and it might need to be removed if you need to plow it, right? Because you got to run all these little lines. So, like, we have drip irrigation in our backyard that we put in because that saves us money on our water bills. So, it is a great way for farmers to do things, but they have much bigger areas than like my small backyard. So, if you rank the order of irrigation types in increasing sustainability, you should be able to do that. And that's something we can talk about in class. All right, so now we have, one of my favorite words to try to say, Ogallala. I always feel like I'm gargling, Ogallala. So this is the Ogallala Aquifer. It's the largest aquifer in the world. It's underground storage of water between layers of rock that's accessible and can get pumped out. So it's not like a big swimming pool underwater. It is porous rock structures. So you can kind of think about it like sand at the beach, when you dig down at the beach and then fills up with water. That's the kind of thing that's happening in an aquifer. So the Ogallala Aquifer, let me just show this to you a little bigger, is huge, right? It's under Nebraska and Kansas and Colorado and Oklahoma and Texas and New Mexico. It is a large aquifer. It's the largest one in the United States and in fact the whole entire world. And what's happening here is people are pulling fresh water. So there's fresh water in an aquifer, because as the water trickles down and permeates the soil, it leaves behind all the salts. So the water underneath is all clean. It's kind of like a Brita filter in your house. Like when you filter the water, the soil actually does that. That's what Brita filters are built on, the idea of how the soil works. So you can pump water out of aquifers and then use it to water crops. So that's why there's a lot of crops grown in this area. It's like where a lot of corn is grown in Nebraska. And they use the water there. They've been using the water there for a long time, and they're starting to use it up too fast. When you use an aquifer too fast, it's called overdrafting. And then when it refills, naturally, it's called recharging. And so we have been overdrafting the Ogallala Aquifer for years and years and years. So it's a big problem, and it almost always comes up on the AP test too, Ogallala Aquifer. They love to like point to it on a map too, so that's good to have. So you guys have a picture of it right here in your notes, right? So wrong way. There's the Ogallala Aquifer. And so then you're going to watch this case study about the Ogallala Aquifer. And that's page 15 in your notes. And then we're on to pests after this. Bye.